Okay, so I'm really excited about this workspace here. There's a couple bays that I've got inside here, and I'm sharing this building with some other guys, and they're all great guys. The guy that side of me, he wants to build SOLN1s over there. There's another guy here who builds organic farm tools to help with organic farming, and he's got all kinds of machinery and metal CNC machines, all kinds of stuff back there. But this is the space I'm setting up to work in. And I'm really excited because I've really been needing some workspace like this to take my projects to the next level. Okay, so here's the beginning of the real-time solar project. And what this is going to be is a couple 20-watt panels connected, and they'll fold up on each other. And inside I'm going to have a small boost pack using 2.7 volt 50 farad capacitors, boost caps from Maxwell. And they'll go inside there. So I'm going to print a 3D housing case for those capacitors to hold them so I can connect them all in series and put them into the pack. And over here I've got the 3D printer set up. I've got the computer. I'm going to go over the process of setting up a 3D print. Okay, so the first thing we want to do is set up the scale, and I'm going to be working in millimeters here. So we'll basically take one of these and we'll get the measurement on it. So you can see here that this one's coming at 18.3 millimeters. So now that we got our measurement that way, we're 18.3 that we're going to go on the diameter of the cap. We're going to go ahead and get the length on the capacitors. And they're, say, 40.5. Okay, so now that we're here inside 3D Max, the first thing we need to do is create a cylinder to represent the capacitor. So I'm going to go ahead and lay that out here, and you'll see that the radius, we measured the actual diameter of the capacitor to be 18.3 millimeters, so we want a radius of half that. That'd be 9.15 on the radius, with a height of 40.7. So that sets, oh, whoa, that's way off. 40.7. So that represents our capacitor. So now that we've got our capacitor here, we can lay them out, and we'll go ahead and we'll create 6 of these little guys. So there's, we'll leave a little space between them, but let's go ahead and do that, and we'll say that we want to copy out 5 more of them, and that gives us our 6 capacitors. So we've got that ready. I'm going to go ahead and just group those, and I'm going to call them caps. And now we've got our 6 capacitors. Let me just go ahead and center those up too. You can see that right now they're nowhere near center. Okay, so now that we've got our capacitors laid out, the next step will be to create the actual plastic part that we want to make. So I'm going to go ahead and create a just a basic box here. And we'll go ahead and we'll play with some of these distances. First thing we want to do is center the box, just like we did the capacitors. So we'll put that on 0. If you work off 0 on X, Y, and Z, it makes everything a whole lot easier. So now you can see that would be a pretty large chunk of plastic for the size capacitors. So let's go ahead and experiment with this a little bit. We want just a little bit of plastic material around the edges to hold the capacitors, but we don't want this too thick because it has to fit in the profile of the solar panel. So, but it would be nice if it's large enough to be strong. So there's always trade-offs. But I think that looks pretty good. Alright, so that would be the base. And then height, of course we can play with the height on this. How thick do we want this? I don't think it needs to be all that thick, so let's go with something like that. Alright, so that looks good for the base. Now one thing to notice, if we look in another view here, like the left view, you can see that we've got the base here, and the base comes to the same level as the capacitors, and we want to pull the base down just a little bit, so that the capacitors don't stick out through the bottom, and there's some actual plastic material there. And so let's go ahead and give that a little more height and compensate for that. Alright, so we've got that. Let's go ahead and copy and paste this object up to here, so they'll have a top part and a bottom part. So now we got that in line. That's starting to look pretty good to me. Okay, so at this point, let me think about this. I'm real close to printing this. The only thing I'm concerned about is getting a little more strength out of this. So Tell you what, let's go ahead and turn on the wireframe so we can see the wireframe as we work. And let's turn on some length segments. You can see the length segments there. And let's go for 5 length segments on the top and bottom here. Okay. So there we go. We got 5 length segments, and let's go ahead and do some width segments here. We'll bring these out until they get out to the edge like that, which is 12. So we're going to go ahead and bring out 12 height and length segments. So you can see that object set up pretty well there. Now what we want to do is we'll go into the edit poly mode, and the first thing I'm going to do is attach the top box to the bottom box. I'm going to use the attach feature. Now they're attached. Now we'll go ahead and we'll edit some faces. So we got the bottom face there, and we'll go to the top face here, and let's see if we can bridge between those. There we go. So what we did is we really just connected the top and bottom faces, and I'm going to do that in a couple places, and that will just really make this strong. So let's do it again here. Bridge. Alright, and let's do it over here. We'll bridge that one. Bridge it in the middle. And one more. And this little guy is almost ready to print here. So we'll bridge that. Alright, so the only problem at this point, let me go ahead and exit out of the polygon edit view here. So the only problem at this point is when we remove these capacitors, you can see that we really just have a block of plastic, and we really want the plastic to hold these capacitors. So at this point, what I really need to do is something called a Boolean operation. And all 3D software operates pretty much the same way, so the techniques you see me using here will be pretty much the same in other software. But I'm going to go ahead and go to Compound Objects, Pro Boolean, and the type of Boolean we want is a subtraction. It's already set there, so I can click the capacitors and it subtracts those out. And now we're set up. So that's an object ready to print. Okay, so now that the part's ready, all we need to do is export it. We're going to export it as an STL file, and I'm going to just go ahead and put it in my 3D parts category, and we got the Real Time Boost Pack folder. We'll throw it in there. So let's just go ahead and name this. We'll call it Real Time Boost Pack, and we'll save that STL. And if you come over here, and this represents the 3D print space, this cube. And we can open that part into there, and you'll see here it is, the STL part, and it lays it out right there on the space, ready to print. Okay, so here's our little boost pack capacitor holder that we built up in 3D Studio Max, and all I really have to do here is basically hit print and go over a few settings, like the quality. On this one I'm going to do fast. On quality, there's a few things under preferences, like the fill material. I'm going to leave all these on default. So let's go ahead and we'll just hit OK. And what's going to do now, if you look down here in the lower corner, it's calculating all the layers. There's 274 layers. It's basically slicing this object into a bunch of slices, and it'll print it down layer after layer. So it's going to get to 274 layers, and then what it's going to do, it's probably going to come up and say it doesn't think it has enough material, and that's because I switched rolls. It actually keeps track of the weight on a roll, so it will actually alert you if you're beginning to run out of a roll. I switched rolls, so it thinks it's low, but we're not going to worry about that. And now what it's doing is it's sending the layers to the 3D printer, and that's what the blinking light over here is about. So as soon as it sends the layers over, I will turn the video back on and we'll watch it start to print. Okay, so all the layers are sent over and it's bringing up the print tray. You can see some of the lines hanging off there. I'm just going to break that off. What it usually does first, it'll usually lay down a little strip of material. That's what's going on right here. And then it will lay down the rafting. And the rafting is really what holds the model down on this perf board while it prints. If it doesn't do that, it can warp and come up on the edges, but with this rafting that it's laying down, that will hold the model down while it prints. So that's the beginning of the process. We'll come back later and check it out. Okay, one trick that I've learned when you're printing something that spans the whole board across like this, sometimes you'll want to warp and bend up the center of the board because the clamps are on the outer edges. If you're printing something along like this, and this is the farthest over this way that it's going to come, one thing you can do is put a couple clips here, and that will help hold that board down. And normally, depending on what you're printing, you may not want to do this because some of the things you're printing, this tray will actually shoot all the way back this way, and those clamps would actually hit this support right here. But in this case, it's never going to move back past these clips. So as long as the clips are just this side of it, everything should be fine. Alright, well, this is printing along here. One of the nice things about this particular printer, the Affinia printer, is that I can unplug it from the computer and it will carry on its print process. So I'm going to pack up here, I'm going to run home, we're going to have lunch, and we'll come back and check this after lunch. Okay, so you can see the support structure that it's going to lay down across the edge. So now it's going to create the upper surface. Okay, so I've ended up in a situation here where there's no more filament coming out of my nozzle. And I've had this issue with this filament. This is the third time this Octave 3D printer filament has had a bulge in it, and the bulge gets stuck in the extruder. So anyway, I'm going to go ahead and turn off the print now. And this is actually functional and usable. It's just going to have kind of this, just in here. Alright, so when I press this in here, I can see that even though we gave a little bit of extra slack, the fit is really, really tight. Let me try one of the other ones here. So I could probably force these in and get this to work, but I might chance cracking something. So what I think I'm going to do is I think I'm going to remove, these capacitors have a heat shrink covering. And I'm just going to remove that covering, and then I believe these will go in just fine. And the only thing you have to remember is that the negative is the shorter leg. So yeah, with the covering removed, this is a perfect fit, and there. So that's it. We'll get the rest of them in there, and then I'll solder them together and we'll try this out. Okay, so this is the last capacitor, and I'll go ahead and we'll get these all soldered in series. But you know what? Looking at this now, I don't think this top pattern even looks that bad. I think it looks kind of cool. So that's the, if the other was a mini boost pack, I guess this is a micro or a nano boost pack. But I'll get these soldered together, and we'll have the negative off this side and the positive off this side, and we'll test this out. So we're going to connect up the positive and negative leads on this, and I'm going to connect to the short leg, the negative. You just want to do one and then do the other because you really don't want to mess up on your polarity in something like this. Okay, so we've got our positive and negative leads on here. I'm just going to go ahead and prep the ends here a little bit. Okay, so I started to charge this up on my power supply, and I was checking the voltage between the cells, and I noticed some of them were not balancing, and I figured out why. I'm used to working with these that have an insulated cover, and you can see that some of the leads were actually touching the aluminum casing, and that was shorting them out, not letting them charge up correctly. So I went ahead and reheated the solder, and I left enough space for me to get my X-Acto blade between the casing and the covering, and I'll insert an insulator in there later, but right now I just want to charge this up and do some tests with it. But that's something to note. If you ever take the insulation off a capacitor, you may end up in a situation where one of the leads shorts to the case. And as we know from the CapTra experiments, that can actually short out a capacitor. So anyway, okay, what we've got here is a real-time SOLN1 system, which means we've eliminated the battery on this unit. This unit is super lightweight. It's catching the solar energy, it's bringing it into a nano-sized boost pack, and it's running that out to a AC inverter. And that's what's powering this light right here.